So now what we're going to do is we're going to do a tag team demonstration. I'm going to switch it off to Kyle Hutchins, a trainer and from McNeil and Associates, and he's going to show us a part that he wants us to machine. Just one moment.
Hi guys. So this is a part from a client that I had a while ago, and this is actually a full-size race car. We designed a body. This is for Advanced Composite Products. The owner of this company's name is Kerry Hitt, and he's also a championship-winning Trans Am race car driver. And so his company builds and manufactures carbon fiber bodies for IMSA Trans Am body or Trans Am race car chassis. And so in the course of this project, we not only designed all of the body parts. Each one of these pieces are giant chunks of foam that they then machined and turned into molds for to lay up a carbon fiber body. But we also were looking at the wheels, and I figured that this was a kind of a nice part to focus on to do this demo. So basically, the way these things come is they come with an inner shell, an outer shell, and a blank for the center. And the center can be machined into anything that you want, and then the assembly basically just bolts together. You have an inside, you have an outside, and then you've got, oops, you got two copies of an inside. And so these three pieces then bolt together with a gasket or some sealant to create an airtight wheel that you can then, customize or do whatever you want. And the name of the game in racing is obviously speed costs money. And so the question is, how fast do you want to go? And one of the things that makes race cars fast is either adding power or adding lightness. And so one of the things that they like to do is they like to design really lightweight wheels that reduce the amount of weight that's spinning around and affects the suspension and all that kind of stuff. So we worked with Kerry and his team to come up with a wheel design for this aluminum blank, and this is pretty much what we came up with. And so the prep for designing this thing, or the prep for passing this thing off to machining, is first of all just doing a couple of checks. And let me just run this in shaded mode so we can see exactly what's going on here. The first thing we want to check for is any naked edges, and in this case it's showing no naked edges, no non-manifold edges, which means this is a watertight part which is suitable for machining. And then what I would do is I would just say File, Export Selected. I would export this as an individual file, and in this case, since we're using RhinoCAM, I can just send it out as a 3DM. And then basically what I'm going to do is I'm going to send Don or whoever it is that's doing the machining a part that looks like this. That's orient. I like to orient stuff around 0 just because it satisfies my personal sense of symmetry. And then I just am going to do one more couple of inspections. I'm going to run cell open polysurface. It says nothing lights up, no objects added to selection, which means this is a closed object. And then the last thing I'm going to do, just to make myself feel good and sleep better at night, is I'm going to run the check command. And check command is going to come up and say this Rhino polysurface object is valid. Okay, there's one more command we can run, which is what, and what brings up all sorts of stuff in here. The most important things are it's a valid polysurface, and it's a closed solid polysurface with 700 surfaces. All right, so it doesn't have anything in here. It's also got some data as to what's going on. All of this stuff passes my checks, so I feel good about handing this off to a machinist knowing that it's going to be in good shape. And so I would just basically save this part, and then I would email it or just file transfer it over to somebody like Don. So at this point, we'll go ahead and simulate that process, and I'll say, Don, I just sent you that part, and you can jump in and take a peek and see what kind of mess I've given you. But I think it's actually in pretty good shape. So.
Okay, Kyle, if you want to send it over to me, I'll go ahead and take control here. Okay, can you all see my screen again, I hope? And let's go ahead and we'll get the RhinoCAM part up. This is the part that Kyle sent us to machine. And obviously Kyle did all of his checks, but there's a few things that when you machine a part, first thing you do is just look at what you have that you need to machine and what is your strategy going to be to machine this. Now, what we've done for this part is we obviously have some fine surfaces here, but we also have a lot of open areas, a lot of pockets. We got some closed pockets. We got through pockets. So what I've done for this part is I've created some masking surfaces to mask some of these areas off to just help in the machining process. And I'll show you these masked surfaces up front, and then you'll see how they come into play when I show you the toolpaths. So we've just got a list of a few masking levels here. We've got mask 1, which basically covers all the holes on the outside, and it covers the large spoke pockets on the inside. But you see that the cover for the spoke pocket is at a depth below the tangent of this radius, and this depth is equal to the radius of the tool that we're going to use to cut this. So when our finishing tool goes over this area, it's only going to go down right to the tangent of the radius. It's not going to go down in the pocket area. So also, let's look at our mask 2, and that's just another masking on the bottom side, which again covers the pockets, covers these holes on the outside. This is for roughing and finishing, so we don't want to cut down into those pockets during the roughing and finishing process. And it extends this surface on up a way so that the tool does not ride this edge of the part. So those are the two main masking layers. We do have another one which is relatively insignificant, so let's turn them all off for now. So let's go ahead and load RhinoCAM. And what we're going to do for this part is we're going to machine the bottom first. So it's a double-sided part, obviously. So we're going to have in our first setup is we're going to machine the bottom side. So let's split this over and show you the stock. It's a cylindrical blank stock. Dimensions about 14-inch rim for a 14-inch rim, about 3 inches tall. So what we're going to do here, and I'm not going to program it all, we've already programmed it, we're just going to show you the strategy that we use to program it. So we started out with mask 2 on, so let's turn on mask 2, and we did a horizontal roughing operation. We'll turn that toolpath on. So with mask 2 on, it roughs out the entire part from the bottom in levels and ignores all the pockets and the holes and everything like that, just the contour. And I'm going to show you all these toolpaths, and then we'll do a quick simulation of it. And then we'll do a spiral finish, and then we'll do a radial finish, and you'll see that the radial finish extends up past the top of the part to the surface that we added up here to get a nice clean finish on that bottom edge of that hub. And then also the hub, top of the hub face, and then the outer profile lip with this mask on, and then the very outer profile, and then the chamfer on the hub is going to be machined on the bottom side. We don't have the hub, the whole machined yet, but we have the chamfer machine. So let's go ahead and run this simulation so you can see what this looks like. And we'll do them one at a time since we're doing pretty good on time. Let's speed this up.
Hey Don, there was a question on how you actually created those mask surfaces, so if you can talk about that.
Yes, well, let's talk about that a second. Now, the mask surfaces, let's go over, and on the top, in Rhino, we simply used these edge curves and created a surface from these edge curves. and just closed that as a perimeter curved surface. And then we dropped it down by a distance of the radius of the tool, of the cutter. And then these are just, planar surfaces across the holes. And this is a swept, planar swept surface using the centerline section of the part itself to sweep that around. And then on mask 2, it's very the same. We just cut a section across the part where we have all material across the part, and then just sweep this bottom section around to create a surface that's identical to the part, but without the pockets. And then this one here is just a straight extruded cylindrical surface on the top, using this edge of the pre-existing edge of the part. Okay, so let's go back into our our simulations, and let's go ahead and run our spiral finish. And if anybody else has any questions, just type them in and we'll get to them. So there's our spiral finish, and then we'll do our radial finish. And you'll see how it gets a nice clean edge there across the top, because we're not riding on that edge, we're just going up past it. And if you don't want to wait for the whole toolpath, you can hit pause and then to end. But we're doing pretty good on time, so we'll go ahead and let it simulate. Then after that's done, we'll go ahead and machine off the top face. And let's slow this down a little bit. And then we'll do the outer lip on the outer profile here. And if you want to see the toolpaths on that, this is just to get a clean lip on this bottom side. And then we're going to do the outer perimeter in a similar manner. Let's speed this up just a little bit. Okay, and then we're going to do the chamfer in the hub on this side. And let's just slow that down here. Okay, so now what we're going to do is we're going to flip this part over on the machine, and we'll probably have a cradle that will clamp this with some, probably some side action compression clamps just holding this together underneath, and we'll indicate off the center of the blank on the top. And let's go ahead and look at those toolpaths on the top. Now, this requires mask 1, excuse me. The first operation, actually, we're going to finish the outside perimeter. Then we're going to do mask 1, and then we're going to do a roughing on the entire top of the part with our holes and our slots and everything masked. Now, the inside area is not masked, so we're going to rough out these pockets in the center hub. And then we're going to do a re-roughing operation with a smaller tool and just pick up some more material that we can get at with a smaller tool. And then we're going to do our first finishing operation, which is a spiral finish. So we're going to spiral all around the part, and you'll see that the tool path comes down onto our masking surface so that the radius of the tool matches the radius of this of the part here around each of the spokes. And then to get a good finish, typically you want to match a spiral with a radial in the opposite direction so that you get a good clearance of material. And for this demonstration, we've got a little bit large step overs just so you can see the toolpath. Obviously, in production, these are going to be tighter and get a lot of better finish on the part. And then we just go through and we cut our pockets. Let's turn off our mask surface 1. We get the pockets, and then we get the smaller pockets, and then we do the cleanup profile in the center of the hub, and then we get our outer perimeter decorative pockets, and then we pre-drill our lug holes, and then use pocketing for our lug pockets. Let's go ahead and do a simulation of this. Speed this up a little bit so we can get through this. So there's our outside perimeter. There's our roughing. Just turn this toolpath off so you can see a nice roughing pattern there. And then we'll do a re-roughing with a smaller tool. Again, just to get a little bit more material off, reduce some of the stress on that finishing tool. And let's do our spiral finish. And obviously in production, the step overs would be a lot finer, so you wouldn't see as much cusping here. But for the demonstration purposes, it gets the point across of the approach. And you see that we're not catching all of the stock material in around these pockets, and we're not worried about that because we're going to pocket those spokes out as a separate operation. What we're concerned about here is the finishing around the spoked areas, all the nice fillets and the radiuses around the spoke and the lug holes. If anybody have any questions, just go ahead and enter them in, and we'll get them answered for you. Okay, so there's our spiral finishing. And notice we didn't go all the way down. We stopped here. If you look at we limited it to this level right here because we're going to do a profiling operation to clean up that, the center hub area. So let's do the radial finishing. And you'll see that for this radial finishing, we had these flat areas selected, which means that in RhinoCAM, when you have nested selections, for instance, for this operation, we selected the outer diameter, and then we selected these flat areas. So the tool is not going to go in and cut these flat areas because they're already cut to spec. So we're just cutting the radial areas around the hub pockets. Let's go ahead and speed this up a little bit. Turn this off. Let's go ahead and pause that and just go to the end. As you can see, as the parts get larger, it gets a little bit longer to calculate and to simulate. And that's one thing to think about when you're designing as well as when you're programming it.
So Don, are you running this in Rhino 5 or 6?
This is Rhino 6. Yep.
Rhino 6, okay.
It's RhinoCAM 2018 in Rhino 6. So there's our radial, spiral and radial finish completed. So let's go ahead and do those spoke pockets, and we'll just get through it here real quick. But you can see here the strategy that we used relating to the pockets, the finished areas versus the pocketing areas. We don't want the finishing tool to obviously ride down in this pocket area. So that's why we had the masking surface on top. And then we come back after and do the pocketing. So you get a nice tangent, clear edge on those hub walls. Then we'll do the smaller pockets. There's a cleanup pass, profiling pass for the center hub, and then we'll do the decorative outer through pockets. These are two operations. One's to cut the pockets that go all the way through, and if you can see the tool paths here if you want to see them as it cuts. And these are spiral pocketing with the helical entries. And let's go ahead and do the blind pockets as well. And then for the center lug holes, we're going to do a deep drill. We're going to do a brake chip pre-drill to pre-drill these lug holes. And then we'll do a through pocket to finish the lug holes. So that's it. That's the finished part. And that's how one approach. There's more than one approach to machining every part, but that's the approach that we took for this particular part. Again, if there's any questions, go ahead and type them in and we'll get to them. So now what we're going to do is we're going to go back to our slides here. Let me just pause this for a moment. So I hope everyone can see that demo slide. Thanks, Kyle. We appreciate it.